Okay guys, demagnetized, cleaned, lubricated, new belts installed, and azimuth set properly. And here's 13, 14, 15 kilohertz, and level minus 1 decibel, and by 12 kilohertz at minus, oh, it's plus 2 decibel, now it's plus 1, and at 10 kilohertz it's exactly plus or minus 3 decibel. And like it will keep it, so the difference is between 400 Hz and 10 kilohertz we have minus 3 decibel level, and up to 15 kilohertz we have up to minus 1 decibel. So it adds plus 2 decibel. It will give a good sound. Technically I have to tune it, and that should be it, unless like I have request from customer to replace this accumulator battery and replace capacitors. Okay, but I like to listen before do any actions, and I need to discuss with owner like what to do. Okay, thanks for attention. See you soon. Hello everyone, and here I'm just completed recapping this deck. As you may see, most of the capacitors are 1 microfarad because this deck is using NGM op amps, which has FET transistors as a result on the inputs, and as a result it uses very low current, and that's where like Nakamichi went with smaller values. In other decks we usually use mostly 4.7 and 10 microfarads. So here is like 4 cups here on the inputs, 2 on the output. On the Dolby boards we have playback amp 2 cups. This one is a record amp 4 cups. Here is input amp, I believe 4 cups there, and 6 cups on the source tape switch right here in this area. Alright, that's everything like which affects sound. So sound goes through these capacitors, and that's where I'm do replacements because this capacitors is 40 years old, and fresh capacitors will give a better sound. Okay, so the next step would be connect everything and start tuning. See you in the next part. Hey guys, and in this part I will be tuning Nakamichi CR-7A deck. So technically it's any CR-7 European or universal version, or even Japanese version CR-70. They all tune it the same way. So I'm connected the test box. So it's a bunch of buttons and diodes, technically to just give command to CPU to go min max values. So, and let's start from the service manual. Let's see tape speed adjustment. We need to adjust to 3 kilohertz. So let's check how it's performed. And it shows 2969.72. Right. It keeps speed really well, but we need to adjust. It's a little bit too low. I would need a small screwdriver like that to get into the hole on the direct drive motor board right here. I'm not sure. I believe you should be able to see it. You see it? Right there. And okay, it gets to 992. So lowers. Oops, it's too sensitive. 377, 38, 24, 20. 3000 to 996. 3001, 3002. Good. 3000 even. 2999. 3004. Okay, 3000 even. Okay. So we have speed adjusted. So we don't need speed tape for now. Next step is meter level calibration. Get 400 gears to the input jacks. And we need to use AC voltmeter to test point 101 to 1 on main board. And adjust levels. Okay. Let's do 2 volts, 400 hertz. Okay. I have voltmeter connected to my oscilloscope, so I will use my oscilloscope probe. To measure the voltage, because we need AC voltage. Okay. Let me see, I have 2 probes. This one. No. This one. Okay. Now, give me a moment, I have to find test points to connect, and I'll meet you right there. And here we go. So this test points is, one is here, other is right here. So there is 2 posts when we can connect the probe. And as you may see, 400 gears is perfectly going through. And our goal is to set 350 millivolts, which is on the top scale. So the scale is 1 volt. And on the top scale, we get to 3.5. Okay, it would be 350 millivolts. And I had to adjust one channel a little bit with spots, smaller one, because one was given 350, another 360 millivolts. Okay, next we have to adjust VR 106 and 206. Right, and this one's is right these 2 ports right here. To make sure that LED 0 will just start lighting. You see, it lights fully. So let's see how we may adjust this. Okay, it just lighted. And the other one, reducing. And just start lighting. Okay, good. Now we have indicator set, we have level set. Next one, MPX filter adjustment, connect 19 kilohertz, 0 dBV to the input jacks. Or technically we don't interested how much we connect. We still need to adjust coils to obtain minimum reading on the IC millivoltmeter. On the points IC voltmeter to output jacks. Okay, we just need to find a minimum reading. So I will remove the probe. Okay, that's my printout of the all adjustment controls. I will connect back our outputs. Okay, and as I tell you, output level of this deck is you see 10 would be like a 0 decibel level, because we're currently on plus 10 scale, and it has 2 more decibel above 0, and on this scale it shows a little bit more than 1 volt, not critical, like less than half decibel now. Okay, I can adjust using this output level. I can adjust, so we will have 0 decibel as well. You can see both channels. Sometimes even, sometimes not so even due to output port. But when we go high, you see they even, so we have even level. Let's keep it zeros. Okay, that's our input signal. And now we will switch to 19 kilohertz. And you see it's not going through. This means we have MPX filter on. It's off. Signal goes through, and that's MPX filter is how it works. So let me see. Level -20, -30. So it's -37, 38 decibel comparing to 0 level. We may try to adjust, but I doubt we would need to. So there is main PCB, 2 coils, and they see it's like LO1. Let me see, I believe this too. No, it's peaking. Here, LO1, LO2, L201. But I don't think it's a proper main PCB, L101, L201. Here is the main PCB. Here, this proper coils, these two. Okay. So we will raise up the OP board, and these 2 coils are adjusting MPX filter. So what I will be doing, I will be turning coils in one or other direction, and we should find the minimum level on each channel, because they should be cutting off the frequency. You see it's growing, going down, 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 down. Yeah, here. So the lowest adjustment we can achieve is right here. It's around -42 decibel. Okay, and the second coil. -41 decibel. Alright, that's how MPX filter is adjusted on this deck. Moving to the next step, BS oscillation frequency, connect counter and see frequency. We need to obtain 105 kilohertz. So we need to install the tape. Let me reconnect a little bit. So I again need a probe. Probably I would have do it different way to not connect my millivoltmeter to the high voltages. I will just disconnect probe, turn off second channel, use the 1 channel here, and get to the 10 volts limit. Okay, and with 10 volts limit, I would be able to measure. Okay, give me a second, I have to connect. So here guys, I'm connected. I have level 104.86 kilohertz. So I will adjust the coil just a little bit. Now it goes down, 103, 105. Alright, done. And I connected to the record head just to see bias. Now it's 105 kilohertz and we're good. What I like, so they make this part here on the body so I can easily connect my probe. And I like it. Okay. We have bias frequency. Next one, bias trap. I don't think something changed over the years, so it's tuned just once on the bias frequency, 105 kilohertz, and that's it. I may check it if you like. Okay, main PCB. I need to find test points here. 103, 203. Right, let's connect to the test points here. Those are in the record amplifier. Okay, where I put my piece. Here. Okay, let me connect and I will show you. Okay. I need to tune record mode again. You may see the signal. Now let me show you where I'm connecting. So there is a left and right pins. Middle is the ground. And we will be adjusting these two coils right here, or these two. Let me get something. We'll be adjusting these two coils, so they will be removing bias to go back to the record amplifier here. Okay? So let me show you how it will look on the oscilloscope. Okay, here we have the bias which went through the coil. Let me see, I believe this reverse it. Not this one. Channel, other channel. Let me see. So there is 4 coils for bias trap. We need to use, yes, adjust 102 and 202 to obtain minimum. Okay, and 102 and 202, the coils I just did show you. Okay. Yeah, this one is changing. Let me make it bigger. I see it's getting lower. Let me change scale a little bit. Like that. Here we go. It just changes the shape. I don't see it changing the amplitude. So probably I need to connect to millivoltmeter. It would be easy to measure. So let's connect this back. Okay, here on the millivoltmeter. Now I will disconnect right channel. Okay. And here it shows me like 45 millivolts now. Let me adjust. Oh. Oh, let me see if I will just reduce this frequency. I don't see it adjusting. I definitely remember it was when I was working on the other CR-7. It changes, but so small. Here we go. Here we get minimum when I fully put coil. It changes like for 30 millivolts. But this is not what I expected to do. So probably we need to start recording. Maybe I have to remove source signal. Here, it's much cleaner now. Here you see it grows. And when I do coil in, it reduces, but it's fully, coil is fully in. Let me check out the channel. I didn't expect that, so it should work a little bit different. Again, both channels act the same, and we're doing properly. Okay, let me work on it. I believe I need to reread the instruction. Maybe something is wrong, and I'll get back to you. Okay, definitely there was like my error. There is two pair of coils, one or two. Right, 1, 201 and 1. Right. Okay, 101 and 201, and another pair is well, let me see, 202 and 102. Okay, and that's where these two other coils definitely, you see, they affect bias. You see, it gets into the back into the record amplifier. And that's where like we need to find the minimum reading. And as you see, and I continue turning, it goes up again. So we need to find really minimum point. I'm looking into my needle on milliwatt meter right now. But you can use a picture in your oscilloscope. So here is the minimum for one channel. And here is the second channel. Let's see. Alright, let's run here. That's the second channel. See, it's growing one direction, going back, and growing again. So here is the minimum point right here. So that's the minimum reading on the voltmeter. Okay. Next part, we need to connect to the points on the bias amplifier on the connector, and using two other coils get maximum readings on these points using coils 101 and 201. Okay. Let me stop it. I will power off just for the case, because it's tight space and relatively high voltages here. So let's get to the one channel. Done. Now I turn on power. Start recording. And here with this coil I need to get a maximum reading. Oh, I didn't get it. Connect TP104 to 4. Yes, we connected. Oh yeah, give me a moment. I need to check it back why it's not adjusting. Okay, it was easy. I need to install tape ZX, metal tape, and now you see I'm adjusting, and we need to find a maximum value. Okay, it goes back down, so here a little bit more. I'm looking in the needle. Okay, so here is the picking value, maximum on this channel. Now I have to reconnect the second one and adjust the other one. Going down, you see, increasing, increasing. Up speaking and goes down again. Alright, so let's go to the pike. Alright, here. Done. So we just adjusted bias trap filters, and I'm switching to the next step 6, adjusting recording bias, and that's where we have to keep milliwatt meter to the these test points 104 and 204 on the power board. We need to go to rec pause mode, and now we put a ZX tape set in the rec pause mode. We complete it. Set the tape selector to the ZX position. If I believe it's for manual mode. But anyway, let's click it. ZX, yes, we are in ZX. We have connected milliwatt meter. Next, turn 103, we are 103 and 203 fully clockwise. And if you look here, this would be the latest one. So we need to turn them fully clockwise. Done. Connect test unit. Connected. Press test button on the test unit. Excuse me. And then maximum. So test max. Okay. Now we need to adjust VR 104 and 204, and these two guys sitting between coils. Okay. To obtain 80 millivolts on the AC voltmeter. Currently I'm observe 74. I can show you here. Let me show you. So you see we have 74 and we need to get to 80 to digitate here, and we add the 100 millivolt scale. Okay, so that's what I will be doing, adjusting this port to 4 to get to 80 millivolts. Done. And the second channel, we'll do the same. Hey, for some reason it doesn't show me anything on this channel. It was just showing perfectly well here. And we adjusting the second port, 104. Again, this one has 72 millivolts, and I'm adjusting to 80. Done. Okay. Next, return 103 and 203 into its mechanical center position. So done for the one. Done for the other one. And we need to adjust VR 605 and 607 to obtain 70 millivolts. And VR 605. I need my glasses. 605. Here 605, 607, these two guys. Max bias current for the text in this position. Need to get 70 millivolts on millivoltmeter. Come on, some problem with connection. Oh, it shows me 78. And we need to get to the 70. Okay, one channel. And the other one. It was 78 as well. Now we have 70. Come on. Done. Now both channels have 70 millivolts. Yes. Now this 71. I like precision. Done. Now both has 70 millivolts. Switching to the next step. So let me show you. So you see, on the maximum we set 80. Now we have in the middle 70. But we were setting it using CPU in the max mode. So that's, we are on step 10 now, here. Okay, now next one, minimum position. Test and minimum. I'm using my module here. Let me put you better visibility. So I'm using test and minimum now. And you can hear the sound. So it's reduced value. Now we need to use 604 and 606 to obtain 25 millivolts. On this channel I have 25 already. Let me see the other channel. Other is 26 millivolts. And we need to use 604 and 606. Okay, these two on the top. Let me see if I can adjust it easily. Wrong channel. Here we go. Now we have one channel. and connecting their second channel, and as I touch it, it's currently 27 millivolts. Tight space due to multiple wires and connectors. Got 25 millivolts on the other channel. Okay, they ask to test maximum again, so testing maximum. Test maximum. Here we go. Okay, I have 70. Test minimum. I have 25. Good. Now testing the second channel. We have 25. Test maximum. I have 72. Okay. Done. Test minimum 25. Okay. I did repeat, and now we have good values. Okay. Now test center. Test center. Change cassette tape to SX tape. Stop and install ROM tape to match the requirements. Now we have pause, and we need to adjust VR 102 and 202 to obtain 20 millivolts on the AC. I see on this channel 20. That's a good sign. And on the other channel, I see 20, 20.5. Okay, and I need to adjust. VR next one for this channel. Done. Okay. Now we need to install the normal tape. And adjust to 13 millivolts. Okay, I have 14. Adjusting to 13. Here we go. Done for this channel. Wow, why it shows so much on this channel. Right. It shows too much. It shows 40 millivolts for this channel. And I cannot get a proper value. So looks like one of the transistors is bad. That's why on normal tape, owner says that he's seen a different level recording. It just doesn't work. It shows like type 2 tape. Okay. See, so this is one channel, and this is other channel. It just was 13 millivolts. Here on this channel I can adjust, let's see, 13. But they are, for some reason, like they affect each other. And this one. Here we go. Now I can adjust. Okay, and it's 13. For some reason, for type 1 tape, left-right channel adjustments are different. Okay, let me see. Now the other channel. No. Now both shows 13. Okay, so probably this was screw it up whenever it was happening. Now we need to click test button twice. Okay, we're out of the test mode. Done with bias. Next would be paragraph 7 or item 7. Adjust analog digital converter reference voltages. We need to use DC voltmeter. So let's lower the boards for now. So we connect DC voltmeter. Change the angle. Okay, we need to connect DC voltmeter to test point 301. And 301. Let me see where is it? It's right here. So it should be here. We have 301. Found it. It's right here near the microchip. Okay, I'm connected. I see 1 volt. And let's follow instruction. Okay, click test max. Test max. Okay, and we need to adjust VR603 to obtain 2 volts. And we see 195, 196. Okay, 603 is this guy. Okay, we have 2 volts. Next, click test center and adjust VR602 to have 1 volt. Done. Okay, have 1 volt. Repeat couple times. Test max. 2 volts. Test center. 1 volt. Good. Completed. Next one. Test tone. DC voltmeter to test point 105. And 215 on logic PCB. So here is a 105. Okay. Need to click test OST. Okay. Test OC. And click after calibration button on the deck. Done. It shows level on the front panel. Let me show you. So you see, it shows level right here. Okay, the level indicator will light up. Adjust VR303 to obtain 1 volt on the DC voltmeter. I don't see. Let me check the other channel. Still I don't see it. Okay, let me start from the beginning. Turn off calibration mode. Okay. Test OSC. Okay, now. Oh, sorry, it went from calibration. Test OSC. Now level. Now I see 0.95. Okay, I need to adjust VR303. And VR303. Here on the lower board, 400 Hz. So I need to raise this port. 303. Need to get 1 volt. Done. Next, press auto calibration again and bias will light up. Confirm that bias is light up. We need to set 0.93, 0.92, 94, 93, 94 using VR 302. .94. Okay. Repeat steps. Level. One volt. Bias 0.94. Okay. Good. We adjusted tone bias generator. Next would be the level controller gain adjustment, item 9. Okay, let me read through. So there is multiple items in this paragraph. I will get back in a second. Okay, here I'm connecting to the connector CN50, so you may see to the pin 4 right there. Okay, pin 4 in ground, and I measure is 1 volt, so we have 330 millivolts on the output of this pin. Next, what I need to do is connect to the pin 2, okay, and adjust VR105 to obtain same level as at pin 4. Okay, let me connect to the pin 2. It shows smaller level for some reason. Pin 4, pin 2. Okay, adjust VR 105. This one. This technically doesn't change much. They probably mean pin 5. No. Pin 1. It doesn't adjust anything. I forget, we need to click test and center. Test and center. And I don't see anything. Nothing at all. Again, let's go out of test mode. Okay, connect to pin 4. Connected. Rec pause, monitor source. Rec pause, source. Have it. Okay. Let's see if it's. No, it doesn't affect pin 4. In pin 4 we have 300, almost 330 millivolts. Okay. Test center. Test center. Okay. Now I switch to the pin 4, but level is significantly lower, and I can adjust it in very small interval, and 2.5 doesn't affect it at all. Okay, let me read through, check the schematics, and I will get back to you because it just doesn't work for me as described. And hello again, everyone. It's been another day. I've been thinking about what is happening. So I have a theory now, which I will confirm when I will do changes to the schematics. So this item number 9 in the settings list, we were using these ports, right? And we need to adjust level on this adjustable amplification op amp. So here is the adjustment with this optical emitting light diode and optoresistors, right? And the instruction says that we need to use these ports to adjust level here on the output, which will be the same which we're receiving on the input of the record amplifier. So it goes like here is a connector right here. So the original goes to number 4 pin number 4, right? And at the same time, it goes to the input of this amplifier, okay? And when we compare it on the pin number 2, we compare it on the output. And same pin number 5, it's the original other channel, and pin number 1 is output from this adjustable amplification lever amplifier. So that's where like our CPU controls the level in each channel, right, to match the source. So what's happening? So over time, these resistors are changed, so they get a higher resistance. And as a result, the amplification level here is not enough. So we observed the significantly lower voltage, like 20 millivolts or like 200, I don't remember. Yeah, 200 versus 330 on the input. And the adjustment range here is not enough to compensate for this loss. So what I will be doing, amplification level for this op-amp is decided like this resistor R119, which is 30 kilo ohm, divided by this small resistor. As this one increases, technically we need to increase this one to make sure that amplification level will be the same. So what I will be doing, I will replace these 30 kilo ohm resistors with 100 kilo ohm pots to make sure that I would be able to adjust levels of amplification and have the same level on the input and the output when this will be in the middle position. Okay, and then after that everything should work smoothly. This will require me again like disassemble a little bit and desolder work, but I hope after that it will work because I was able to see changes. So here, let me show you. That's the output. You see, about 200 millivolts. Now, let me test. Center. Okay. Test. Maximum, you see, is 260. Test. Minimum is 160 millivolts. So, test. Center is 200 millivolts. Oh, and original, if I will switch to the pin number 4, and original is 320 millivolts. So technically we need like 1.6 time amplification, right, to match input and output. And here is this optocouplers. So they have one LED and two optoresistors. One affects amplification level here on this side, and the other one affects how significantly our original change will affect this amplification, because it will divide our current from here and current which goes to minus 12 volt. So the smaller this resistor, the lower voltage will be here, and the more tough it would be like to go from this plus 12 volts. Okay, so it should like make those adjustments more like linear and more smaller, like, because otherwise it will be just going up and down in two big directions. Okay, so point is I will replace this resistor with 100 kilo ohm pots, and technically we need about 48 kilo ohm, 47, 48 to match the loss as you just seen on the voltage level. Okay, see you soon. Okay guys, as I thought, I was able to overcome this issue. I had to install for one channel 100 kilo ohm pot, and for other channel 500 kilo ohm pot. So uneven it was. Okay, now take a look. Checking pin number 2. 350 millivolts, and pin number 4. Oh, it was 4, now 2. 340. Okay, almost there. And like the other, pin number 5, 360, and pin number 1, 340. Okay, I can adjust just a little bit, but now it's almost even, and now we have a full range of adjustment. Take a look. If remember before, we were looking into a pretty minimal adjustment, so now we are in the middle, right? And before, adjustments were like between like 160 and 260 millivolts. Now take a look. Maximum 720, minimum 180, and center 350. Okay, it's right there. And I was using this box. And let's check how the channel, what we get there. Maximum the same 720, minimum same 180 millivolts, and center 350. Okay, cool. Now everything works, and that was the root cause. The customer was telling that during recording, one channel records weaker than the other. Okay, because there was not enough range to adjust differences on the tape. Okay, congratulations to the owner. I hope you appreciate my knowledge. Let's move on. See you quite soon. Okay guys, we just completed with item 9 from the adjustments list. So we make sure that our level controller gain has enough range to adjust, and the input and output voltages are matched. So next is like adjust playback head azimuth center position. So that's where we put this into the center. Let me turn it on. Okay, so this should be in center. And remember the port here. Let me put the boards down. Okay, just a moment. It's complicated. Come on. Okay, let me put the boards down. Right. Remember this connector from the azimuth port, and we have potentiometer right here. Okay, that's where we will be adjusting. So it says press test button and center button. Test, center, and you see it should be matching in the center position. And with this port, we may adjust it. No? No, I don't see it. Okay, let's see. With this one, it doesn't adjust right now. Probably something is missing. Arrow mark corresponds to the indicator plate on the mechanism chassis. Okay. Center, adjust the potentiometer. Arrow mark on the cam corresponds to indicator plate on the mechanism as shown on figure 3.5. Alright. Let's find figure 3.5. Three, 8, 7, 3.5. Azimuth capture. This one, this potentiometer should be adjusted. Alright, and we need to see the position. It's not so easy to get there. It's required removal of this board because it sits right there. Okay, let me play around it and I will get back to you. Here guys, to make these settings, I had to remove this panel, put into the center position. Here on the wheel we have arrow, which should be pointing to this like metal piece right here. I hope you can see it. So this metal piece right there, and there is arrow on the black ring. And port is right here. So with this port, we need to install the center position. It was very close, just maybe 1/2 off. Okay, so moving on. So now we completed with item 10, going to item 11, azimuth reference position adjustments. So connect test unit, turn playback azimuth control to its mechanical center position, press test button, press AZ button, and adjust VR so that ready indicator lights up. Mode play. Oh yeah, so I suppose we need to play tape. And I will put tape with azimuth. Frequency sweep. Oh yeah. Power on. Okay, mode play. Okay. Test azimuth. Okay, now we have to turn this VR608. Let me see where it goes. Yes, it's azimuth position. We need to turn it so this mechanical center here. We will be turning this guy till ready. Wheel lights up. So turning left, no. Turning right. Here. Ready. Done. Complete with this item. Next, azimuth indicator adjustment. VR609. Play mode. Connect. Press test center. Okay. Test center. It shows center. And now adjust VR609 to have the position. We have it. Test max and see that all segments lights up. Yeah. Maximum, minimum, center. Everything works. 13. Playback head, track and azimuth alignment. Monitor, hitcher and playback head azimuth alignment screw. Test center, track tape. I would not touch height because we didn't touch it. Tape and adjust playback azimuth. So now we need to connect oscilloscope. So let me do it. Sorry, I need a different head. And now connect to the output. Now okay, we're out of test mode. My oscilloscope just hang on here. Oops. Oscilloscope just hang on. And we have perfect azimuth. No need to adjust. Alright. Moving on. Playback level. We need to load level tape. play it back, adjust VR 104, 204 to obtain on test point 101 and 201, 350 millivolts. Test points so small. This diagram 101, 201, okay. Let me put it on pause. I need to first of all install the level tape. Okay, next pull up boards. Okay. Next, connect oscilloscope differently again. Oh, now that we need millivoltmeter. So what I will do, I will connect like that. Alright, now connect the probe. Let me put you on stand. I need 2 hands to do it. Okay, connecting. Done. Now playing. And we need 350. We have 370 millivolts. That's where we will be adjusting playback amp. Right here, I believe. That's 104 and 204, yeah. These two guys on the playback amp. Okay, 350 millivolts. Now connecting to the second channel. And it has 360. So using the second port to adjust a little bit. Okay, 350, done. And next step, playback frequency response adjustment. Play the tape. We have R143, it's only if it's needed, so we can short resistors on the board if head is worn and frequency response is not there. So we skipping item 15. Now item 16, we need to record and check that record head, azimuth and height are proper. Let me do it. So I'm installing the type 1 tape. Turning on record mode. Let me connect oscilloscope so we can see both channels. Okay. And I can see that it's a little bit off, so let me show you. So for 400 gears it's off. Let's see XY. Yeah, you see it's open. We need to adjust a little bit record head azimuth to make it perfect. Opens, closes. So that's the best one. Now we will switch to probably 8 kilohertz. Let's see. So the difference between one click on the azimuth gear. That's left one click, you see, it's egg, middle, it's line, and right one click, it's egg again. So how precise it is. Alright, so we have record azimuth. And now we can check it right here. And these records. And now we see that levels are different, left, right channel. That's what we will be tuning next, I suppose. 17 phase comparator adjustment. Okay. It's required to put in metal tape, put into the record mode, set frequency 400 Hz, okay, and adjust VR304 on test unit center, test center, okay, and adjust VR304. Phase comparator. So we have azimuth indicator lights up. So 304, it's right here in the middle. Let me check one more time. Yes, it's this guy. And we need, yeah, azimuth is not lit, so I'm turning slowly. One direction, now other direction. Again, test center. Here we have azimuth indicator lit. Here you see, I click test center, it shows center here, and I was adjusting VR304 unless this azimuth indicator would lit. Okay. Next. Record play, feed 400 Hz, test level. Test level. Okay. Test level. Now click after calibration. And something doesn't work, it's just calibrated itself. Let's stop. Let's try one more time. So I'm trying to follow instructions. And here is this long list for item 18. We connected test unit, install ZX tape, feed in 400 Hz. We have 1 volt, I believe. Switch to the source. Yes. Okay, we have 1 volt on voltmeter. Set the monitor selection to the tape position. Done. Press test level button. Test level. Don't see changes. Load ZX tape, put in the rec play mode. Done. Now click after calibration button. After calibration completed and the radio indicator lights up. And just okay, let's see when it's completed. Done. Now we have to adjust VR101 and 201 to update 0 dBV on the AC voltmeter. Yeah, and we have a difference. You see how far it is, like a couple decibels. VR101 and 201. Let me see. It's probably like that, yes. Found. Now pull up these boards and it's these two guys here. Okay, interesting. Have 1 volt and there's the one. Okay. Have it. Now source tape. Even change cassette tape to SX. Okay. Done. Set rec play, run calibration and adjust rec play. Now run calibration. You see how off signals were? That's because those calibration unit was off. You see, it cannot complete because it's too off between two channels. Okay. Let's try one more time. Let's bring them closer. You see how far they are. Okay, now when they're closer, let's run calibration. I hope it will complete successfully. Okay, let me take a look into that. So, for some reason it doesn't work for SX tapes. See you soon. Well guys, there is something wrong with the chrome tapes. I tried 2 tapes, they don't calibrate, don't tune up. So metal tape, for example, I can run, I can calibrate, and I adjusted so they shows proper results. Okay, we need to adjust one more time a little bit to have 1 volt. Even position. Technically it is close. I was able to do it on the normal tape, the same procedure. But on the metal or on the chrome tape, you see, so run calibration. On chrome tape, 1 channel recording is very low. It's like 3 or 4 decibel lower. And you see like one volt here. So again, source, tape, no difference. Right. When I install chrome tape, I tried 2 of them and they show the same results. It cannot calibrate and like I cannot set a level on 1 channel. So you see, right channel is fine, and left channel is 2 decibel lower, and it's maximum. And on the right channel I can go much higher. So something wrong rather with this circuit or with this microchip, which switches between these different levels. I need to do more investigation, and if I will run calibration now, it will fail. It adjusts azimuth, but it tries to adjust level and bias, and it's failed. Okay. I need to see if it may be bias problem or level problem. Okay, this will require some more time. See you soon. Hey guys, and I continue investigation of the issue with the calibration for SX tape types. I check it up levels here. I don't believe the levels are issue. I'm all like more or less connect, but when I start observing the bias, you see 1 kilohertz, 2, 3, 4, 5, 6, 7, and one channel is goes out. 10 kilohertz, there is no channel. You see? So there is a problem with the bias, so I need to check what's going on with this other board. So see you soon. Technically, I see the same, not same, but similar situation on the ZX tape. So you see, if I'm increasing frequency, one channel is significantly lower than the other. So it's 400 kilohertz, 400,000 hertz, okay, 14 kilohertz. And you see how different left-right channel is on the bias. So the same as the levels here. You see something is definitely wrong with the bias in this deck. So that's where I will be looking now what's wrong. Okay. And it was working before. I'm not sure. But we were recording just 400 hertz. Okay, let me see one more time. I will be repeating 0.6 record bias adjustments, and let's see if it will help, or probably we have an issue and need to replace parts. See you soon. Hey guys, and I'm connected two probes to left and right channel to see the bias. I see bias 105 kilohertz on one channel, but other channel generator just died. You see it doesn't work, so there is three generators. One is for the primary one, which is connected to rise head, and there is two other generators which are synchronized from the primary one for left and right channel, so that they can adjust amplitude programmatically from the CPU. And as you may see, it was working. We were tuning like 80 millivolts, and now we see 80 millivolts just on one channel. Another channel won't work. And we currently in ZX tape. Okay, so it's pretty weird. Okay, center. Let's put rec pulse. 80 millivolts test. Minimum test. Center test. Maximum. Why? I'm just lost what is happening. One of the generators doesn't work. So I have to open and see. Maybe those orange caps are problematic. So let me see. See you soon. And hello again. So what I did, I replaced these two capacitors on the power supply on the generators. Then like one of the ports was not properly contacting, so I was like deoxidizing it and like going back and forth, and this did help. Okay, then I had to readjust bias all over again, and then adjust levels. So now I can show you what I get. So it's a metal tape, quick record, quick calibration. So it's adjust azimuth, bias, and then levels. You see ready? And that's what we have on the output. So source, tape, pretty good. Source, tape. And it was metal tape. What I mentioned is that this deck would not record precisely without calibration. I'm not quite sure of the reasons, but if you follow the procedure to tune it and then use calibration, it works perfectly well. But if you don't use calibration for the tape and just start recording, the levels may be off between left-right channel. And I tried to tune it, but then the calibration mode would be different a little bit. Okay, so it would be like that, you see, without calibration. Now running calibration. And everything normalized. You see, levels proper. So source, tape. See, perfect. Source, tape. Perfect results. And it's chrome tape. And the last one would be the normal tape. Okay, so recording, calibration. And I'm doing it in the test mode. So in the normal mode, you would not be running calibration during recording. So here we go. Source, tape, source, tape. And here, source, tape. Good. Levels calibrated. Okay, next we have bias already calibrated initially. It has a quite sophisticated procedure. I believe I'm running out to the end of the calibration procedure. Let me check. Yeah, so it was 18 record level calibration. We just did it and it's successful. Record amplifier equalizer adjustment. Supply 23 kilohertz, minus 20 decibel. Connect voltmeter to ports 103, 203 and use 2 coils. It require remove BS cut jumper. Obtain peak reading. I don't think that we need to remove BS cut jumper because everything is quite simple. That's 2 coils. We have it right here. So we measure signal here on 23 kilohertz and make those coils to peak. Okay, so even I don't need recording. I just put on pause. Go to 23 kilohertz. Okay, I need to connect probe. Technically, just connecting it to one of the inputs here. Let me adjust levels. Maybe we don't need bias. No, we do. So they propose to cut bias, so it would not be. Okay, now I have 73 millivolts. And if I will be adjusting the coil, I can make it maximum, right? Source. Here we have bigger level. Okay, so it's modulated by 23 kilohertz. I'm watching my millivoltmeter and I cannot see anything. Okay, let me remember how I did it. I did it on my previous deck, not mine, as a customer deck before. I will get back to you pretty soon. And here we go. So I'm recording 23 kilohertz minus 20 decibel, and we will be using this coil on this channel. So to adjust peaking, I see it gets to the maximum and then goes down. Okay, so here is a peak. Come on, what's up? Goes down, goes up. Okay, so that's the maximum position. Now we get the other channel, 23 kilohertz, and we will do the same. This coil, see it goes down. Come on. Okay. Here is the maximum. Here. Tune it. So 23 kilohertz is the best possible recording with tuned filters. And it was the last one, L103, L203. I don't have remote control to connect. And I'm going to show you what we've been tuning right now. Okay, and it was main board. And we've been tuning these coils. So it was adjusting the response for the record amplifier. So this one is a record amplifier or pump. And we were adjusting the peaking so it would respond with this heads on the 23 kilohertz really well. Okay, tuning is complete. Now let me assemble it. I will connect computer and we will do final measurements what we received with this deck. I believe it will be perfect. Thank you. See you soon. And here guys, I'm assembling and I remember that I had to replace battery, so I installed the bed when we can replace battery easily. And to avoid questions, so here is a battery was installed. It's not accumulator, it was replaced a while ago and it's already CR-7 like 3022 or like 3220, something like that. 3-volt battery, and I installed a similar. Okay, probably accumulators were not well available. Right now they are available on Amazon. If you will replace, you would need to install diode, so it would be charging. Now I will use zip ties and we should be good. See you in a moment. Hey, hello everyone. This would be the test, final test after this Nakamichi CR-7A has been restored, tuned, all issues eliminated. So let's test together. I haven't seen much myself yet. So let's start from the level. So you see it's a 0 level as a source and 0 level there. Now installing tape, playback, tape, and here is a tape. So source, tape. So you see levels are ideal. Next, let's check valve and flutter. I will be switching to the valve and flutter view. What we have 0.0, 54, 55, 52, and frequency is 3001 Hz, which is a very good result for this tape transport. So they average around 0.05%. Okay, the best one I've seen was 0.04. That's it. The reason, I believe, capstans are a little bit rough at this age. They are not even, and I'm not sure. I never seen this tape transport providing good results. Okay, going to the level, and let's see frequency sweep spectrum. Here we're playing so 400 Hz, 2 kilohertz, 3, 4, 5. Level is even, both channels goes good. 8, 10, maintain level. 12, 14, and 15. A little bit higher, 2 decibel on 15. Okay, good results. Next, let's do test recording. I will switch to white noise minus 20 decibel. So here is the source. Let's do automatic calibration for this tape. And I'm starting recording. So it's source. You may see how nice it is, and now it's tape. The only difference is like very minimum. You see, so one square is 2 decibel, so difference like less than half a square between 4 kilohertz and 16 kilohertz. So here again source, see it's 7 up, and here is a tape. Ideal results for this tape type. Really cool. Again, source and tape. Perfect. If you like, we can do frequency sweep. And it's type 1 tape. And it's tape. Yeah. We're recording. As you may see, both channels extremely even. I see good bass here. Good bump at 15 Hz. Goes really even, left and right. And 5 kilohertz here, like a little bit difference. Very minor between left and right channels. 16, 18, still recording. 19, 20. So 20 kilohertz minus 3 decibel. Okay, go back to white noise. Let's see, -10. And this records almost flat on type 1, -6, and 0 decibel. Pretty good results. Okay. Next, let me put type 2 tape. Let's calibrate. Now here we're recording. Again, very good results. So, source and tape. Technically, almost no difference. Let's see, -10. It's flat, left channel a little bit lower, like maybe 1-2 decibel. And 0 decibel, what we see. Okay, it's not metal tape. Still pretty good results. And let's check metal tape. Okay, I'm recording, and it's tape. Very good results. So -10. Good. And 0 decibel. Very good. Okay. Very nice deck. So now I'd like to check how it plays music. Let me connect headphones. We'll reduce level. Okay, see it plays, and it's azimuth. Yeah, you see it adjusts high frequencies, no high frequencies. Everything works well and smooth now. You see I can adjust little by little and it still will work perfectly well. In all range, okay? Good. And I hear good sound and levels are there correct. And this tape has been recorded on another Nakamichi CR-7, so they are pretty compatible, everything is good. So that would be it. I will do a sound demo and we'll ship it back. See you soon, guys. Hey guys, as you see, deck is playing perfectly well. One last thing about this deck. I was upgrading it, and I remember I upgraded the previous one a couple months ago. And my feeling was that this deck was sound a little bit flat on the bass, right? So what I did in this deck, I replaced it 4 capacitors, C141, 241, and 2 capacitors on the record side, 101 and 201 with 2 microfarad, 2.2, not 1 microfarad. And you know the bass is there. It sounds so well now. Highs there, bass there. Like I like it much more than the previous one, which was on factory values. Remember when I was fixing those decks, I told you that I won't even try to put 4.7 microfarad. Despite these op-amps has a FET transistors on top, on inputs, and like they are low current, these capacitors really significantly improve the bass Now it's not flat, it's live, and I really appreciate it. So stay tuned for the video with sound demo. We will be recording, we will be playing, and I hope you will like it. So that was a deck with all Nakamichi CR-7 issues in one package. So we fixed all of them. So I hope this will help in your research if you will meet similar problems. So let me know your thoughts about this video, if you did like it, if you like more similar videos, and I will be continue doing it. Thank you. See you. Bye-bye.